All right, in this video, we want to solve these exponential equations over here. So let's start with this first one over here. Now, if we take a look at this equation, you can kind of tell it's a quadratic equation because we have the same base here, but this is 2x and this is x. So the first thing we should do is substitution. Let a equal to 3 to the power of x. So now I can replace this 3 to the x with an a, so that becomes a squared. This will become minus 5a equals to negative 6. Then we just solve it like a quadratic equation, so I'll move the negative 6 over. And then I'll factor it. So what multiplies to 6 adds to negative 5? It's just negative 2 and negative 3. Then my two solutions for a are just positive 2 and positive 3. Once I figure out my a, I have to replace it back with 3 to the x to solve for x. So for this one here, I have to use logs to solve it. I'm going to log both sides and bring my exponent down. So x log 3 equals to log 2. Then I'll just divide the log 3 on the other side. And that would be my final solution. If you are allowed a calculator, you could do log 2 divided by log 3 in your calculator. You should get 0.63 rounded 2 decimal places. For this one, my exponent is 1, my bases are the same, so I just know automatically that x equals to 1. I don't need a calculator for that one. So two solutions in this first question here. Let's go to the second question over here. In this second question, I noticed that I can make all three bases the same. So that's the first thing I'm going to do here. I know 2 to the power of 5 is 32. The next thing I can do is I can combine these using my rules of exponents. If I have two multiplications with the same base, I'm just adding the exponents. I'll also write it in order as well to make things easier. Now I have the same base on each side, so I can cancel that off. And again, this is going to be a quadratic equation over here. I'll move the 4x and the 5 to the other side. And then I'll factor this. What multiplies to negative 5 and adds to negative 4? So my two solutions for this one are positive 5 and negative 1. Let's go to the third and fourth question here. Third question here, again, I can make these two bases the same. So that's the first thing I'm going to do. I know that 3 to the power of 3 is 9. And if I bring that to the top, it becomes negative 3. Then I can multiply these two exponents here. And now the bases are the same, so I can just cancel them off. And again, this is going to become a quadratic equation. To solve, I'll move the 9x to the other side. Two terms that multiply 20 and add to 9 are just 5 and 4. So my two solutions are negative 5 and negative 4. And let's go to the last question here of this video. Impossible to make the bases the same, and I have x in the exponent on both sides. So the first thing I'm going to do is I'm just going to multiply. I'm going to log both sides on multiply. Then I'm going to use my rules of logs, split these up. So this is log 2 plus log 3 to the x equals log 7 plus log 5 to the x. Then I'll bring my exponents down. That's the whole reason I logged both sides. Now we have x and an exponent and you can't get rid of the bases. You want to always log both sides so that you can bring your exponent down using log rules. Then I'll bring the x terms to one side and the log terms to the other side. So x log 3 minus x log 5 equals log 7, and I'll move the log 2 as well. So minus log 2. Then I'll just common factor out an x here. Now I'll divide both sides. I'll divide this on the other side basically. And there are ways to combine these as well if you had to further reduce them down. For example, you could just divide these two numbers and these two numbers, and you could combine the logs using log rules, but this is generally acceptable for a final answer. If you're allowed a calculator, you can put this in your calculator. And if I do that, I will get negative 2.45 if I round to 2 decimal places. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.